Page 94, question number 7. The reading comprehension scores for junior high students at Oregon Middle School are normally distributed with a mean of 80 and a standard deviation of 5. So before we even read parts A, B, and C, I'm just going to make a sketch of this normal curve. So I've got this very rough sketch of a normal curve. The mean score is 80, and since the standard deviation is 5, we can label these parts on our graph 75 and 85. Okay, first question says, what percent of students have scores greater than 87.5? So 87.5 would be about here. Greater than that would be this entire region to the right. Okay, I'm going to let my calculator do some of this work. Since we are looking for a percentage, we can go into our distribution menu, second variables, and looking for a percentage, we're going to use that normal CDF command. When we use this command, we need to type 4 pieces of information. First, we need the left and the right bounds of our shaded region. Well, the left bound, 87.5, we're given. Now the right bound, we don't know how high this extends. So for a right bound, I want to just say it extends infinitely high. So if I press second comma and then 99, E99, our calculator interprets as infinity. Now the next two things we need are the mean and the standard deviation. So this is like saying find the area under the normal curve between 87.5 and infinity if the curve has an average of 80 and a standard deviation of 5. So that area is about 0.07, I'll say 0.066. So about 7% of the curve is shaded right here. Now next one, similar question. It's saying what percent of students have scores less than 78? So 78 is about here. Less than 78 is this shaded region. And this shaded region we can see is bigger than the blue one we had before. So my answer is going to be bigger than that first answer. Okay, so I'm going to get that normal CDF command again. We're looking for a percentage under the normal curve. Left and right bounds. Now, we don't know for sure if the lowest score can be 0, but I think it's a pretty safe assumption. And in fact, 0 is so far away from this average that even if 0 isn't quite right, we'll get an answer that is going to be close enough for our purposes. So we're looking for the percent of scores between 0 and 78. And again, we need to type in our mean and our standard deviation. And we find this percentage is about 0.34, about 34%. Now, part C, much different question here. What score is needed to be in the top 10%? So looking at our graph we have here, where do we have to fall to be in the top 10%? Let's say top 10% of all students get a scholarship or an award. What score would get you in the top 10%? Well, 80 gets you at 50%. 85 probably isn't quite it. We want to know what score we'd have to be on the scale so that 10% shaded in. Now, our calculator will do that for us as well, but it's not the normal CDF command, it's inverse normal. We use inverse normal if we know a percentage. Now, careful, here's the percentage we know, 10%. The command on the calculator always wants to know the percent to the left of whatever your value is on the scale. If you put in 0.10, you'll get an answer over here, higher than 10%. If you're in the top 10%, you're higher than 90%. So I'm going to type in 0.90. And then again, we need our mean and standard deviation. So inverse normal, we need just 3 numbers to follow our command. When we do that, we get a value of 86.4, meaning any student with a score above about 86 or so, which is about in this range here, will be in the top 10% of all scores, which seems to make sense.